Reversible BIM is a digital tool that provides insight into potential of building to be deconstructed with high recovery and reuse of materials in mind. Reversible BIM is a three-dimensional building tool built on Elma Durmisevic, which performs digital reversibility assessment of a building structure and measures reuse potential of building and its materials. In order to do so, the model analyzes relations and dependencies that individual elements have within a building structure. With deconstruction of existing buildings in mind, reuse potential of materials is mainly determined by their technical and physical dependencies within a building structure. These dependencies reflect their hierarchical position. 8 indicators of reversibility are listed here, highlighting indicators of technical and physical dependencies which have main impact on high-value recovery of material. Assessment of the indicators results in a reuse potential score, a number between 0.1 and 0.9. Reversible BIM uses color codes from green 0.9 to red 0.1 in order to visualize assessment of reuse potential. Processing of data through Reversible BIM has 7 presented steps. Reversible BIM relies on 3D point cloud files form 3D scanning. Point cloud data is imported into Revit as the main modeling reference. Point cloud file illustrates scanned surfaces of the building. 3D scanning files are mapped with technical drawings or models which provide additional information not included in the point cloud, as for example, the layers between the scanned surfaces. Mapping of point cloud files with technical drawings is verified on the site when needed. Once geometry has been verified, basic BIM model is created following reversible building methodology and taking care that all elements are clustered according to their main building function and can be counted and their relations analyzed. After basic BIM is created, reversible BIM plugins are used to provide additional information. The user assigns a connection type from the standardized list to each pair of connected elements. A list of all connections of an element is visible in the View Element Data window. Once connections are assigned, a color-coded view based on the connection type is reported. A special tool has been developed to enable the user to assign the appropriate assembly sequence number to each element, as well as to include it into parallel assembly groups. 3D Viewer enables non-Revit users to view the model and the contained information through several custom-made views that reflect the reversible BIM principles. Besides information about the type of element, its position, dimension, etc., 3D Viewer is color-coded. Color coding is based on the element functions, disassembly sequence, number of relations between elements, reversibility, and reuse potential of its materials. The Reversible BIM tool currently provides several types of reports in graphical or numerical form, such as relational graph, visualizing all relations between elements. Graph is color-coded, reflecting reuse potential and number of connections per element. Color-coded views based on the number of connections, reusability potential, list of all connections made during the assemble of one element. Reversible BIM contains useful data outputs for decision makers such as position, dimensions, M2, volume, and the most importantly, reuse potential of the material. Reuse potential score of material corresponds with the reuse options of material and gives an indication of the embodied value in the material. Finally, a BIM objects library of all elements with high reuse potential is made available to the architects. Such catalogues will boost reapplication of valuable materials in new designs.